Azmi, Nurul Listyani. I'm from State University of Malang, Science Education, from offering C. This is my video about light spectrum.
Light is electromagnetic radiation within a certain portion of the electromagnetic spectrum. The word usually refers to visible light, which is the portion of the spectrum that can be perceived by the human eye. One of the characteristics of light is that it behaves like a wave. As a result, light can be divided by its wavelength and frequency. The frequency is how fast the wave vibrates or goes up and down. The wavelength is the distance between two peaks of the wave. Frequency and wavelength are inversely related. The electromagnetic spectrum includes a wide range of light waves, some that we can see. Some of the non-visible types of waves are radio wave, microwave, infrared rays, and X-rays. These types of waves have all sorts of uses in science and technology. In the visible spectrum of light, the color of the light depends on the frequency. The visible spectrum is always the same for a rainbow or the spirited light from a prism. The order of colors is red, orange, yellow, green, blue, indigo, and violet. A fun way to remember this is by using the first letter in each color in order to spell out the name Roy G. Biv. This expression it ranks the colors of light in order of increase in energy. R is red, O is orange, Y is yellow, G is green, B is blue, I is indigo, V is violet. Light is part of an electromagnetic spectrum, the same spectrum which contains radio wave, infrared, ultraviolet wave. The humans respond to wavelengths from 390 nanometers to 700 nanometers. The color of the light is because of different wavelengths. To the left of the red light, you have infrared, which is outside of the visible light spectrum, we can see it. Now past the violet, you have ultraviolet. Ultraviolet radiation you can be exposed to that from the sun. We are going to focus on the visible light spectrum. To the right, the frequency of the light increases, so a photon of blue light has higher frequency than a photon of red light, because blue light is to the right. Blue light also has more energy than red light. However, red light has a longer wavelength. So, as you can see, the colors here are ranked in order of increase in frequency and increase in energy from low to high. The wavelength is ranked and decreased in order from very long to very short. At this point, this is at 700 nanometers, and at the edge of violet is 400 nanometers. Between violet and indigo, it's above 400 and 450. Blue light the range from 450 to about 500 nanometers. Green light range from 500 to about 570. Yellow is very small. It's 572 to 590. The range limited. Orange goes up from like 592 to 620, so red is from 620 to 700. What is the color that corresponds to a wavelength of 530 nanometers? So 530 nanometers is between 500 and 570, so that will be a green photon. From the explanation above, can be concluded light spectrum is the many different wavelengths of energy produced by a light source. Light is measured in nanometers. Each nanometer represents a wavelength of light or band of light energy. Visible light is the part of the spectrum from 380 nanometers to 780 nanometers. Remember Roy G. Biff. To the right, the frequency more high. To the left, the wavelength more longer.